Alright, so today we are going to go ahead and work on Chapter 13, Section 2, Angles on a Coordinate Plane. So here we have a coordinate plane, the x-axis and the y-axis. You are first going to be asked to recall what the quadrants are. Go ahead and take a few seconds to look at quadrant 1. There it is. Go ahead and try to find quadrant 2. This is sometimes forgettable. Yes, it is on the upper left-hand corner. And then from there, we can find quadrant 3 and 4. Now we're going to go ahead and put in some of the degrees. We haven't done this yet, so listen carefully. We will start here at 0 degrees. From there, if we move counterclockwise in that direction, we will find where 90 degrees is. And then if we continue to go in that direction, we'll know that 180 degrees is right there. And then furthermore, the next one over, a little bit harder to remember, but it is 270 degrees. And then finally, if we wrap all the way around, it turns out that 0 degrees is the same as 360 degrees. Alright, let's go ahead and do an example to find arc measures. You are going to be asked to sketch the angle in standard position, write what quadrant it lies in, and then find the coterminal angle between 0 and 360 degrees. And I'll explain what coterminal means in just a second. So let's start off with 50 degrees. We're asked to sketch the angle in standard position. And so if you notice, 50 degrees is somewhere in between 0 and 90 degrees. And in fact, if we go halfway in between, that'll be 45 degrees. And since we don't have a protractor to work with, we're just going to sketch. We're going to estimate where 50 is going to fall. It should be a little bit past the halfway mark, right around there. All right. Obviously, it falls in the first quadrant. And then since 50 is already between 0 and 360, 50 degrees is also the coterminal angle. All right, let's go ahead and do another example. Let's go ahead and sketch where 179 degrees is. If you notice, 179 degrees is a little bit less than 180 degrees. It's actually 1 degree less. So we're going to try to guess where that is. It's going to be a sketch, and I'm going to draw it freehand because I don't have a ruler and then I don't have a mouse either. So 1 degree is about that much. All right, we don't have a protractor, so I'm just estimating. It's a nice sketch, but from here to here is 179 degrees. It does fall in the second quadrant, and then since 179 is still between 0 and 360 degrees, the coterminal angle for 179 is still 179 degrees. All right, let's go ahead and do another example. 400 degrees. Now if you notice, 400 degrees actually wraps around the whole coordinate plane once, and then it has a little bit more. Your job is to figure out how much more past the 360 degrees. And it's not too difficult. It turns out that 400 is 40 degrees past the 360 mark. So this is an extra 40 degrees. All right, so we have figured out that the 400 degrees is going to be in quadrant 1. And now here's where the coterminal angle comes into play. The coterminal angle for 400 degrees is 40 degrees. It's basically the extra leftover after it's been wrapped around. So it's, if you want to consider that as like a reduced version of 400, 40 degrees is the same as 400 degrees, but it's in between 0 and 360 degrees. So it's like a reduced version. Let's do one more example. (2,000 degrees). Now, as you can imagine, 2,000 wraps around the graph many times. To figure out how many times it wraps around, go ahead and do 2,000 divided by 360 degrees, and that'll give you an approximation. It's about 5.5. So it turns out that our graph will wrap around 5 times. But then there's leftover. You have to know how much is left over, the coterminal part of it. All right, and that's easy to figure out too. All you have to do is do 360 degrees times the 5, just the 5, not the 5.5 that we found out earlier up here. And that gives us 1,800 degrees. And then you just have to figure out how much more to get to the 2,000. And that's pretty easy to do. 2,000 minus 1,800 is just 200 degrees. And that's where we have to find where the coterminal angle is. 200 degrees more. Here you look at 180, 200 will be somewhere around here. All right, so there's our angle in standard position. It looks like it is in quadrant 3. And the coterminal angle, the leftover angle from here to here is 200 degrees. Let's go ahead and continue with another example. What about negative 15 degrees? What do you guys think negative 15 degrees means? Yes, it means we're going to move in the opposite direction, this way. So you're going to move in the clockwise direction 15 degrees, which is about that much. So there it is in standard position. It does lie in quadrant 4, and now we have to figure out the coterminal, the angle in between 0 and 360, this part. And that's fairly easy to do. You just take 360 degrees and minus 15 degrees, and it turns out that the coterminal angle is 345 degrees. All right. Here we have an open-ended question. They want you to figure out one positive and one negative angle for 25 degrees. So you have to figure out another angle that is the same as 25 degrees, that is positive, and then one that's the same as 25 degrees, but it's negative. And that one's really easy to do. To find the positive number that's the same as 25, you go ahead and you just add 360 to 25 degrees, and you have 385 degrees. Now there's infinitely many answers. You can continue to just add 360 every time, and all of those answers will be the same as 25 degrees. But that's the most simple way. To get a negative answer, you just subtract 360 degrees to get negative 335 degrees. That is going to be the same as 25 degrees. And then again, if you continue to subtract 360 degrees every time, all of those answers will be equally correct. All right, let's go ahead and find the arc measures just given a point on the coordinate plane. Here we are given point -4, 4. And they are going to ask you to find the angle measure for -4, 4. The first thing we do is we draw in the angle, going from the origin straight through -4, 4. Now we have to find the measure of that angle. To do so, we have to draw in a triangle. And then kind of worry about the distances of the legs of that triangle. We know that distance is 4. I know it's in the negative direction, but for distance sake, we'll just write +4. And then that length is 4 because it goes up 4. So the legs of the triangle are 4 and 4. This is when we have to think about special right triangles. If you have a triangle that has legs 4 and 4, you should remember that the angle inside is 45 degrees. All right, so from there, we will figure out that that angle is 45 degrees. And then to find the measure of this angle, we can figure out that it is 135 degrees. It's the 90 plus the 45 degrees. And that's how we find the measurement of that point. Now it also says in the directions to find the negative angle. So to go from here this way. And that's also easy to do. You just have to take 360 and subtract 135. And that should give you negative 227 in the negative direction. Here's another example. This is a much weirder point because it's -5 radical 3, comma -5. We have to find that angle. Let's go ahead and first put in the angle, and then we have to find the measurement of that angle. Same thing, we're going to throw in a triangle. Know that that leg is 5 radical 3. The other leg is just 5, and this also is a special right triangle. If you remember those properties, you will remember that this angle is 30 degrees, which now makes it fairly easy to find that angle. It's just 180 plus the 30, and that gives us 210 degrees. To find the negative version of that answer, we go this way. It's just 210 minus 360, and that gives us negative 150. So the last thing we are going to do today is figure out what the reference angles are. The definition is the shortest measurement to the x-axis. It's the shortest measurement you have to go from the angle to the x-axis. Let's go ahead and do an example. We have to find the reference angle for 100 degrees. Go ahead and plot where 100 degrees would be. Right around there. Again, it's just a sketch. But to find the reference angle, it's the shortest measurement from the angle to the x-axis. That is called the reference angle. And it turns out to be 80 degrees. If that one was 100, to go the rest of the distance would be 80 degrees. So the reference angle is 80 degrees. Okay, let's go ahead and do a few examples for reference angles and then we shall be done. 210 degrees. 210 degrees is approximately right here. To find the reference angle, it's the distance to the x-axis. So from here to here, the x-axis, the shortest distance. That one's also pretty easy to figure out. To go from 210 back to the 180, it's only 30 degrees. All right, let's go ahead and do another example. $15 degrees. Let's go ahead and sketch out where 15 degrees might land. Should be somewhere right here. Okay, the distance from that angle to the x-axis is right here, and it's also 15 degrees. So the reference angle for 15 degrees is 15 degrees. Pretty simple. Let's do one last example and then we're done for the day. $300 degrees. Go ahead and find where 300 degrees would be. Should be somewhere around here. The reference angle is to go from there to the x-axis. And it turns out the reference angle for 300 degrees is 60 degrees. All right, that is all we have for today. Thanks for listening. Enjoy your homework.